Welcome to the Discover Mathematics series. In this video, we're going to see how people can discover the rules for the addition of integers on their own. To assist them, I'm going to use a two-colored chip. One side is positive, and the other side we're going to use as negative, because the red's going to be negative, because generally people think of red as being negative, such as a stop sign, checkbook, papers being returned from the teacher. If you don't have two colored chips, you can have one side of the paper clear and one side shaded. You could also use coins. Okay, but for this demonstration, the yellow side is going to be positive and the red side is going to be negative. So let us begin. Now, in order for people to figure out the rules for themselves, they're going to have to notice a pattern. In order to notice a pattern, you have to have all the problems like each other so they can see what's going on. Okay, so for the first problem, we have 2 plus 3. So we can model that with 2 positives and then 3 more positives. And then we see that we have 5. Now what I would like for the students to do is to actually draw this on their paper so it will serve as their notes. I'm going to use green instead of yellow because I think it'll show up better when you go to, when you're looking at it. So I would have a positive 2, and then I would have 3 more, and this gives me 5. For the next problem, I have 1 plus 4. And we will see that answer is also 5. So we would sketch that as a 1 plus, and that answer is also 5. When we look at the next 2 problems, we have positive 4, 4, plus 2. And if we sketch that, so we will have something to refer to. 1, and then we have 2 more, and that gives us 6. And then on the 4th problem, we have 3 plus 1. And then we can see that that's 4, and we can model it, sketch it as 3 plus 1, and the answer is 4. Okay, so all the problems are very much alike, positive and a positive. And what do they notice? At this point, they would probably say, well, it's just regular addition, which it is. But it's one set of problems, a positive and a positive. So it's just, that's what they've done since they were very young. Okay, now let's look at the next set of problems. So we have a negative 3 plus a negative 1. So the negative is red. So we're going to have a negative 3 plus a negative 1. And then we see that we have a negative 4. So when we sketch this, negative 3 and a negative 1 gives us a negative 4. The next problem, problem number 6, we have a negative 1 plus negative 2. So here we have negative 1 and negative 2, or 2 negatives. So our final answer here is a negative 3. The next problem, we have negative 4 and -3. I'll put it below so you can see it. 1, 2, 3. And what we see here is we have -7. So we have -4. And then we have -3. And this answer is -7. For the next problem, we have -5. And -2. And we see we also have -7. So here we have -5. And -2, and the answer is -7. And so by this point, people will probably have noticed a pattern. And you can do more problems, or you can go right to where you ask them, what do they notice? And if they need more, if they don't notice a pattern, then they can do additional practice problems. But if they do, then you can ask them, what do they notice? And most people will notice if you have negatives and you're adding more negatives, then your answer is the combined total of those negatives. So the negative is acting like a label. It's what you have. You have negatives and more negatives, your answer is going to be negative. Now let's see what happens when the signs are different. So in this question, we have a -3 and a +1. When we go to build it, we have a -3 and a +1. And I'm going to put the +1 below, and you'll see in a moment. Now, because they're different, I can't do anything with it. So we need a new rule. And here the rule is a +1 and a -1 give us a 0 pair. We're going to refer to it as a 0 pair because it's like going to the left and then coming back to the right, you're at 0. So this amounts to 0, but we're not going to say they cancel out. They're just going to give us a 0 pair. So if this gives us a 0 pair, then I'm left with, so this is 0, and I'm left with 2 negatives. So when I go to write this on my paper as my notes, I'm going to have -3, and I'm going to put my +1 below, and I'm going to circle it as my 0 pair, and then I see that I have 2 negatives left. So this gives me a -2. Let's look at the next problem where I have a +1 and -2. And then I see that I have a 0 pair, which I'm going to move aside, and I'm left with a -1. So when I draw this, I'll have a +1, then I have -2, so they're red, and this gives me a 0 pair, and I'm left with a -1. Okay, so we're going to be looking for a pattern of what's happening here. Okay, in the next problem I have -4, so I have -4 and +3. And then I see that I have, here's a 0 pair, another 0 pair, another 0 pair, and you see why I put them underneath each other. And then I'm left with a -1. So when I draw this, 1, 2, 3, 4 negatives, and 3 positives, and here's my 0 pair and my 0 pairs. So I have 3 0 pairs, which amount to 0, and I'm left with a -1. Okay, in the next problem I have -5, -5, and +3. So here I have 1, 2, 3 0 pairs and 2 negatives left. And here are my positives. So I have 1 0 pair. Draw them in first. So here's a 0 pair. Here's a 0 pair. Here's a 0 pair. So I'm left with 2 negatives. So far, all of my problems, my answers have been negative. But that's not necessarily always true. So the next problem, I have -3 and a +2. So then again I see here's a 0 pair, here's a 0 pair, and my answer again is negative. So I'm going to see what's going on here. So I have a -1, 2, 3. So then this gives me 2 0 pairs, and I'm left with a -1. Okay, so we're thinking, what sort of patterns are we seeing? The next one, oh, I have +4, +4, and a -1. Okay, and I'll scoot that way over here. So I have +4, and a -1. And here's a 0 pair, and I'm left with 3 positive. So I have positives. So why do I have positives for my answer now when all the previous problems my answer was negative? So I want them to notice, start thinking about that. Okay, and wondering, should the next problem have an answer that's positive or should it be negative? So we have +5 and -2. So I'm going to draw +5 and below that I'm going to put my -2, and let's see what happens to my 0 pairs. I have 2 0 pairs, so I'm left with +3. So here's my 0 pair. It doesn't matter what color I circle them. And I'm left with a +3. So why is this answer positive? Okay, those are questions that you can start asking, or asking yourself, or asking your students. But people should be questioning, why is my answer now positive when my first problems the answer was negative? Okay, in the next question I have -3, -3, and positive 6. See if you can see them all. Okay, negative 3 and positive 6. So I'm going to put this as a 0 pair. Here's a 0 pair. There's a 0 pair. So I have 3 positives left. So here, even though the positive number was second, I still end up with a positive answer. So I have 3 negatives, 6 positives, 3, 4, 5, 6, and so my answer here is a positive 3. Okay, so by this point we should be noticing some patterns, and that's what you can be having your people can be doing if they're working in a group or with a partner. They can be asking each other, what do you notice? What's going on here? And what do we see? Because there are some very definite patterns occurring. Okay, the next problem, we have a negative 1 and a positive 3. So we see we have 1 0 pair. So when I do that, I have a negative 1, and then I have 3 positives, and my answer is a positive 2. So let's see, what are we noticing for a pattern? Oh, I have, one more question before we go to answer that. Okay, we have positive 6, for positive 6 and a negative 2. Put the negatives over here. So I see I have 2 0 pairs here, and then I have 4 positives left. So I have 6, and then I have 2 negatives, and that gives me a 0 pair here, 0 pair here, and my answer is a positive 4. Okay, so then the question is, what do we notice? And there should be several things that the students notice, or the people notice. Okay, one of them is when the signs are different, because you can stop the video right now and think, what should they notice? Okay, one of the things they should notice is that we had some 0 pairs. And there is a pattern to the number of 0 pairs. And so that pattern is that the number of 0 pairs is the same as the smallest, the smaller number, quantity-wise. So here we have a 6 and we have a 2. So the 2 tells us how many 0 pairs. When the signs are different, a negative 1 and we have a 3. The signs are different, but between the 3 and the 1, this 1 is smaller. There's 1 0 pair. Just looking at the numbers, the signs are different. The number that we have fewer of, like we have fewer negatives in this problem. So because there's 2, we have 2 0 pairs. So when we take those 0 pairs away, we're left with 3. So what's happening is the number of 0 pairs is the smaller quantity. And when we take those away from the larger quantity, we're in essence like subtracting. We're taking them away. And that's why our answer is the same, like here it's 6 minus 2. Because we had 6 positives, we took away 2, and we're left with 4. Here we have 4, we take away 1 0 pair, and we're left with 3. So we're looking at two things. The smaller quantity tells us how many zero pairs, which we take away, and we're left with the quantity minus those zero pairs, the number of zero pairs. So how they want to write that, but it's two different things. The number of zero pairs and then their final answer. So the number of zero pairs is this the smaller quantity, which we take away from the larger quantity. And that's how we come up with our answer. If they don't see it, they need more practice, then continue practicing until they're able to tell you and able to see it in their head what's happening. Because once they see it, then they own the rules, and you don't have to tell them the rules again. But they've got to see it for it to make sense. Thank you.